Uh, Ready? Last time we did the Venn diagrams. So can you I think you know what is Venn diagram now. Like we have a rectangle, then we have circles inside the rectangle. And make sure you know how to draw and to read the values from the Venn diagram. Okay. So now is tree diagrams. So what is tree diagram? Somebody did sketch on Sunday the tree diagram, correct? So basically, a tree diagram, we should have branches, and we should label our outcomes like A, B, and so on. And we should have the probability. Okay. Why we need tree diagram? So because from a tree diagrams, we can get so many informations, right? So you can get obviously the probability, and second one you can see we are talking about total of the probability equals to 1, correct? And from tree diagram we can see, okay, where is the 1? Okay, and from tree diagram you can also see the intersections. Last time from Venn diagram you know the intersection, right? From the tree diagram we have intersection too. And also from tree diagram we have conditional probability. Okay, so basically there are so many things from a tree diagram. Okay, so because there are so many things, so many informations from the tree diagrams, so the first question is make sure we get a correct tree diagram. If you cannot get a correct tree diagram, then you cannot answer the following question. Obviously, you can answer you hentam all the time. Okay, but what I mean is we can get a correct answer from a tree diagram. Okay, I don't want to read the slide here because my point, my focus is at least you should know how to sketch a tree diagram perfectly. Okay, so we have exercise here, all right? So we have two questions here. First one is you are planning a 3-day trip to Johor in October, right? Draw a sunny day, rainy day tree diagram for the trips. Can you try now? How many branches do we have and how many levels do we have? So if you read these questions, if you're talking about level and branches, guys, right. So let's say if you have general one, this one is not the tree diagram for the questions. This one is branches. So basically here we have two branches. Okay, probably we label this one as S bar. So what is our S? Our event. What is S bar? Complement of the S. Okay, so basically this one is level 1. This one is first level, but we have two branches. Okay, so if you go to level 2, it's probably we have two more. So this one is level 1. This one is level 2. Okay, so make sure you know where is the branches and where is the level. Okay, so here we have two levels. So this one is level 1, and the second one is level 2. And each level we have two branches. Two branches. So S here is event, so we have to identify the event. That's why last lecture I emphasized okay, define your event, because we want to use the capital letters on our tree diagram. Okay, And after we label this one, we can put like, probably we put like 1/4, 3/4. So what does it mean here? We label our probability on the branches. Okay, so this one is 1/4, this one should be 3/4. So from level 1, can you see where is the total probability equals to 1? Total is 1, correct? Okay. So what does it mean? If you sketch a tree diagram, the total probabilities for each, not for each, for branches is always equals to 1. Like this one should be 1. This one should be 1. This one should be 1. So what, when I say each branches, okay? So this one is 1, obviously because we have like 2 different branches only. Okay? So what can go wrong is some students, they will think, okay, the whole thing is 1, not the whole thing. Okay? This one should be 1. This one should be 1. That's how we check our probability. Clear? Right? Alright. So first one is, we do this one together. So you are planning a day trip to Johor in October. So first one they ask is, draw a sunny day, rainy day tree diagram for the trip. So my first question is, how many levels we have? How many levels we have? 3. So level 1, day 1. Level 2, day 2. Level 3, day 3. Clear level? Okay. Alright, so now at least you can imagine, okay, we should have like 3 levels here. And each level, how many branches we have? Just now, I believe you get the 3 because 3 day 3. So basically this one, it means, oh, okay. Level, not level 3, like 3 levels, okay. Agree there? Okay, now branches. How many branches we should have? What is this one? Sunny day, rainy day. What does it mean then? 2 branches. Okay. So here for this tree diagram, so first one is, so we have this one, and we do have this one. Okay, this one like level 1, day 1. Okay, probably can we label this one as like, I don't want to label it yet because we have like bigger tree diagrams later. Okay, then we have branches here. Then at the end of the branches, we need to put like capital letters. So in this case, what capital letters you want to use? Yes, SR. Normally we pick the letters corresponding to the event so that we can know, okay, S sunny, R is rainy. So from the tree diagram, you can use A and B, but if you use A and B, like you cannot see like the clearer picture. You have to know A is what, B is what. So if you use S and R, you can say, okay, sunny, R is rainy. So pick the correct alphabet, and my suggestion is to use like the corresponding with our event one. Okay, so this one we want to use S and R. Okay, so if you use S and R, define S and R. So write somewhere S is sunny day and R is limit. Okay, why we need to use this one? Because somebody else might duplicate our answer, so at least like they know what is S and what is R. Okay, so complete day 1. Day 2, the same one. So like we have 2 branches. This one we have 2 branches. This one is S, this one is R, this one is S, this one is R. Okay, and day 3, yes, we have draw properly, guys. Okay, so this one is S, R, S, R. Question. That's how we draw or we sketch a tree diagram. Okay, so then number 1, then this one. Okay, question. Right, so second one is we have to list the sample space. Okay, so we have proper tree diagrams here, right? So where is the sample space? You can put at the back here, like you can write outcomes or sample space. Both are okay. Okay, so we label this one, let's say sample space. Okay, and if you notice, where do we begin like drawing our tree diagram? Where do we begin? We begin it from here, correct? That is like our initial point, our beginning state. Okay, so if you want to draw, like to get a sample space, we should like start from the beginning. Okay, so which is somewhere here, not somewhere here, there, right? And this is the end, correct? But we have day 3, like 3-day trip, like day 3 is the end. So like day 1 is the beginning one and day 3 is the end one. Okay, and how to get here? Basically, you have to go through this one, correct? So if you go that path, what letters you like come across? Yes, this one is, so S, S. Second one, S, S, R. Third one, S, R, S. Fourth one, S, R, R. Next one, R, S, S, R, S, R. So R, R, S, and last one is R, R, and R. So that is our sample space. Okay. All right. Question. Okay. So we done question 2. And question 3, it says list the outcomes of the event it rains all 3 days. So this one is very precise. Like probability, you have to understand the words very precise. Because like if you don't understand it precisely, like it may be like mean something else. Okay, so this one it say it rains all 3 days. So what does it mean here? Yes, we should look for R, R, and R. Okay, so this one. So only one outcome there. R, R, and R. Okay, and how to answer these ones, you can write this way. If you want to write this one, you can write. So R, 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 use the set notations and the curly bracket. Okay. Then this one, next question, list the outcome of the event it rained on exactly one day. So what does it mean here? On exactly one day. Yes, sehari saja, but it doesn't say which day, right? So as long as your sample space, it has one, exactly one R. So how many we have? This one. This one. How many we have? Three. Three. So label all the three. Okay, because exactly one. So your answer for that question is, I don't want to labels there. This one, and this one. How to label? Use the curly bracket one. And comma, like SSR, comma, SRS, comma, and RSS, comma. Use the curly bracket one. Okay. Then this one. And last question is, list the outcomes of the event it rained on at least one day. The keyword here is at least one day. What does it mean? Yes, say something. So basically, what does it mean here? If you look at your sample space, okay, we have eight outcomes here, right? 8, correct? Okay. So we should pick, like, from the outcome, as long as there is like one R, at least one R. So we need to pick 1R, 2R we need to pick or not? Yes. 3R? Yes. So basically we have to pick not semua kecuali yes. Kecuali SS. The whole thing we have to take. Because it say at least 1R. Okay? Except SSS. Okay. Some question they can ask you like raining on the second day. So you should pick like the art in between, the center one. If raining on the second day. Okay. Alright, so we answer this one. And you may ask, like we have nice tree diagram here. We have levels, we have branches, and we have sample space. But we don't have probability on the branches. Can we get the probability from the question? Yes or no? From the question, we cannot assume like 0.5, 0.5. Because we are not given that information. So we cannot label 0.5, 0.5. Okay? So let's say we assume, because I want to explain something here. Do we have example, or they don't have? can I assume something, because I want to explain something. Let's say we assume something. Let's say like we are, because there is something I want to explain here. Let's say this one is our assumption, guys. Let's say like sunny is 0.5, raining is 0.5. Okay, so if you assume that one, so where is 0.5? This one. On the branches then. Okay, and this one should be 0.5, 0.5. Okay, I need to put somewhere. If not, you like assumption as 0.5, 0.5. Okay, 0.5 and 0.5. Okay, again, make sure this one is 1, make sure this one is 1, make sure this one is 1. Okay, and you label all the branches there. So 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5. Okay. Right. So again, this one should be 1, this one should be 1, this one should be 1, this one should be 1. Okay, and we can get the probability here. How do we get this probability, like to have S, S, and S? Like how do we get S, S here? Basically, we like this way, and this way, correct? So if you take this way, and this way, and this way, what probability like we use? 0.5, 0.5, 0.5. Okay, so to get this one, multiply. Like probability across the branches, we multiply. So if you multiply this one, I guess you should have like 1/8. Correct? So probability of getting S is 1/8. Or you can take 0.5, multiply by 0.5, multiply by 0.5. Correct? Can you check? Yes, 1/8. Okay. Yes.
Percentage.
Where percentage where? Dekat sini? On the tree diagram? On the branches?
Kalau let's say ini 1.8, 1/8. Kalau kita buat 12.5%.
Yes, we can. But normally, I say normally, guys. Normally probability, we don't use percentage. Okay. Because theory of probability, like our answer should be like from 0 until 1. Okay. But we can convert probability into percentage. So if you read books, most of the books they will use like 0 until 1. But if some books use percentage, that is not wrong. But you can use, but I prefer 0 until 1. Okay. Alright. What is the second one? Like this one, this one, this one. 1/8 too, right? Okay. Why 1/8 this one? Because like each branches we have like equal probability. Like if you have different probability, then you have to multiply. Okay. So basically here, you will have like 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, and 1/8. Okay. So the next magic thing happens is this total should be 1. Okay. So there are so many ones from your tree diagram. Branches, 1. And the whole thing is 1. Clear? Alright? Okay. What else do we have here? We have conditional probability. We have intersections. Okay, let me explain intersection first. So when I say intersection, I believe you assume or you imagine this one. P, A intersect B, correct? This is the intersection. And last time from the Venn diagram, where is our intersection? Both one. The middle one, right? Or in between. Okay? Correct, that is intersection from the Venn diagram. So here, where is the intersection? Don't look anywhere else. Look at the here. Okay, because your tree diagram is there. Well, where is the intersection? Do you have ideas? Because the problem is like because when we explain the tree diagram here, you can like probably I hope you can sketch tree diagram now, and you can like put the probabilities, and you can list all the sample space. But when question asks intersection, then they all what like why they ask intersection? The tricky one is this SSS. Oh, this SSS here is actually intersection. So SSS there. So this one is actually S intersect S. The outcome or the sample space you list is actually intersection. So if the question asks to find PS intersect S, you should take this one multiplied by this one multiplied by this one. Because that is SSS. Okay, so basically it means S intersect S. Okay? Alright? And last one, what can go wrong is you confuse which one we need to multiply, which one we need to add. Okay? If along the branches, when I say along the branches, this one, we multiply. Okay? Like if you want to get, like let's say you want to get SRS here. So what we do is like we go this one, and this one, correct? Then we get this one, we multiply along branches. But if we have different branches, like this one is 1, and this one is 2, this one we have like 2 branches, right? So if you have like 2 branches, then we add, total up or we add. That's why we add up this one equals to 1. Okay, make sure you know where to multiply and where to add up. Okay, and we have the intersections now from the tree diagram. Clear? Okay. Alright, now I'll try to do question 2 there. A company buy machine parts from 2 different suppliers. Draw a tree diagram that show the 2 suppliers and whether the parts are the supply are defective. Try to do this one. So how many levels do we have? Why two? Yes, because you have two suppliers. So level 1, supplier 1. Level 2, supplier 2. And each level, how many branches do we have? That is the 2. You label, how do we label the branches? Defective and non-defective. So if you, because we have defective there, so like obviously like if you buy something either the product is good or not. So if you label D defective, and then we can use D bar, complement 1. Okay. Can somebody come to the front and draw? Where's the marker? Pen? Okay, go. Try. And one thing you miss. One thing he missed. What is that? Yes. Define your what is your D? Okay. Thank you. Correct, guys? Thank you. Agree? Yes? Yes? Okay. Last time I did say, no, this one is correct, perfect. And if you notice, like I did say, like mathematicians and statisticians, they are lazy persons. Okay. They are very lazy, like including me. Okay. If you define your D, sometimes you don't have to define D bar, because we know what is D bar. D bar is not D. Okay, but just now in our example, why I define like S and R? Because we have like two different events there. Okay, that's why I define S and R. But if you want to define D bar, it's fine, not a problem. Okay. All right, good one. So tree diagram completed. Then. Okay. So this one is again like probability of complement events. So you know what is probability by now, I hope. Okay, I hope you fall in love with probability now. Okay. Complement. What is complement? What? Yes, correct, but not in this case. In this context, we are not talking about pujian. Okay. What is complement? Lengkap. Okay. What is that? Lengkap. Pelengkap eh? Pelengkap. Or D-bar there. In that, our case is D-bar there. An event is? In our case just now is defective is like our events there. Or sunny days, rainy days, that is event. Probably on Sunday you don't see what is our events. Now, yes, you can see what is events there. Okay? Right? So what is the relationship between an event and the complement event is the total is 1. So if you pick PA, or let's say in that case is we take PD plus PD bar, we should have 1. That is the relationship between like an event and the complement event. Always 1. Okay. If you ask why, like total probability is 1. Okay. And these two, do you know how do we get these two? How? Yes, somebody put this way, at least yes. Yes, at least you know something. How do we say in words? Yes, tukar tempat. We rearrange, like either you want PA equals to 1 minus PA bar. If you want PA bar equals to 1 minus PA. We rearrange. Then we can get like the second one and the third one. Agree? Alright. And we have examples here. 1010 United States adults were surveyed and 202 of them were smokers. So if you want to find like probability of smoker, we have to take 202 divided by 1010, which is 0.2. And if you want to pick like P smoker bar, then you have to take 1 minus 0.2 equals to 0.8. This is one way. What is the second way to get 0.8? This one is the first way, correct. This one is not wrong. What is the second way to get like 0.82? We can take like P smoker bar. So we have to take like 1010 minus 202 divided by 1010. What is the answer? I hope 0.8. Please say 0.8. So like there are two ways. It depends on you which one, like which way you see first. Okay? Alright? Alright, exercise 5 here. What is this about? 16 batteries are tested to see if they last as long as the manufacturer claims. 4 batteries fail the test. 2 batteries are selected without replacement. Depart on time, arrive on time. Given that, why given that? Guys, oh, you don't have this one yet, right? Can you snap the photo first? I will share this one. When? Okay. How many slides? Let me check how many slides do we have. 16. Wow. This is a lot. Alright. Try to read question. Try to read only question number 1. Read only. Don't do it yet. Then yes, done reading. Okay, how do we solve this problem? I mean, what method? I don't want to see informations here. Like you want to use Venn diagram or you want to use tree diagram? Which one is easier? Tree diagram. Okay. Alright, so second one is, we have a lot of informations here. First one, we have like 16 batteries. Obviously, we have like 16 batteries. Okay. Second information, we have like 4 batteries failed the test. What is the importance of the second sentence? Because now we decide tree diagram, right? Let's say we decide tree diagram. I don't want to do now. Oops. So tree diagram. Remember when we have tree diagrams, we have to we need to have events. We need to have like probability on the branches. Okay. So what is the importance of 4 batteries fail the test? Yes, somebody say part per 16. What is part per 16? Correct.
1/4.
Yes, 1/4. What does it mean? Correct. Correct. That is not wrong. Okay, don't laugh, guys. It's wrong. But probably I asked like, what is 4/16 is 1/4. What is 1/4? Probability? Fail. So basically like you can use the F letters for fail. Okay. And 1/4. Okay. So okay, see. F is you use fail, capital F, fail 1/4, and F bar. What is F bar? Complement. What is the value? 3/4. Okay. Tapi this one, no, this question is like not really accurate, but it's okay. Oh, okay, that makes sense. And next one is, what is without replacement? Yes, dia ambil, lepas tu dia tak letak balik. Okay. So this one, so in an experiment, you have to pay attention on this word. If you don't have this word, it means like you put back. No. If you don't have this one, assume no replacement. We will mention like if we put back. Okay. So this one is, I don't want to do it now. Go back and try this one because you have class tomorrow. Okay. Oh my, no, yeah, we are fasting, but yes, okay. So you have extra time because we don't have to take lunch hour. Okay. Second question, Mio, okay? Second one, read question number 2. Read first. Then reading. How do we solve question number 2? Venn diagram, tree diagram. Tak tahu is a problem because in exam, yes. In exam, I don't know why you tak tahu, but you will provide an answer. Okay. I think this one Venn diagram is easier. Why? We have like departs on time. Like how many events we have here? We have like depart on time, one event. Second one we have like arrive on time. And third one is depart and arrive on time. That one is like intersection. You see that? Depart and arrive on time. So basically that one is like intersection. So if you have like Venn diagram, probably like you have two circles and the intersection one should be 0.82. Okay? Alright? For this question, my suggestion is Venn diagram. Okay? But don't worry, because like last semester when we set this kind of questions, because this one is like for the learning purpose. Okay? So in exams normally like we will set the questions like question number A like draw a Venn diagram. We will guide you. Okay, like sketch a tree diagram. Like if you don't guide you then we like yes, that is good one too. Okay? Alright, and if you notice here we have like given that and given that here. Right? So even though given that is like given that like simple words, but this one it means conditional probability. Okay, we haven't covered the conditional probability yet. That's why I asked you to go back and do. Not now, okay? Because we will cover now. That's why when I read the question, why they ask you conditional probability if you haven't covered? Okay. Now we will cover the conditional probability. Okay. So now we will cover the conditional probability and the multiplication rule. So what is the new thing from the topic, from the subtopics here? Multiplication rule. Do you know what is multiplication? Yes, darab. So basically like it is related to darab, multiply. Okay. Conditional probability. Syarat. Okay. So what does it mean here? Now you are in Asasi, correct? Let's say you want to go like for accounting. Listen guys, I want to explain the conditional but using the real life, not the conditional yet. Okay. Let's say you are in Asasi now and you decided, okay, I want to do accounting. Later this year, September, October lah. Okay. And then the syarat, the condition is, or the minimum requirement, like normally they put minimum requirement. Basically, conditions there. Okay? And you have to get like, let's say 3.9 for instance. That is the syarat. Okay? And we have two candidates, or two students here. One is 3.95. She or he pass or not? Like, pass the minimum requirement? Yes, then can, like, he or she can apply. But somebody else, like, he or she wants to do accounting, but 3.7. Pass or not? No. Yes, even though like he or she wants to do accounting, but because of the condition, he or she does not pass, like we cannot go there. So in probability letter, you will see the condition. From this condition, okay, go there. Because meet the condition, you can go there. If does not meet the condition, you cannot go there. That is condition. Okay? And multiplication is yes, multiply. Just multiply. Alright, conditional probability. Okay, so first one, I don't like to read slide guys because I know you can read. Okay. Alright, so first one is, we have seen this one, right? Let's say PA. What is PA here? Yes, probability of event A. Correct. What is PA B? A intersect B. Correct. When somebody asks you like, what is probability of A intersect B? Sometimes we like, oh, how to explain to some like, if you want to explain to somebody, my suggestion is use the Venn diagram to explain what is PA intersect B, so that they can see, oh, this is PA intersect B. Okay, and have you seen this one? Yes, this one is union, PA union B. Okay? So now, when we have conditional probability, obviously like we have like not a formula, like we have a way to write or to represent conditional probability. So if you see this one, PBA down here. Oops. So this one is conditional probability. Like if you can see PB bar, not bar, tiang tu, and A. That is conditional probability. So what does it mean? When we mention conditional probability, the first thing I want you to imagine is, oh, this one. That's it. Clear? Okay. And we have this one. So obviously this one is probability of B given A. Okay. This is how we say it properly. And the keyword here is given. Okay. And probability of B given A. Like probability of B given A, this is how we write. Oops. If you have like, let's say if you have P A given B, this one is probability of A given B. Like you may see this one is almost the same, like PA tiang B or PB tiang A, PA tiang B. You may see like only the position, like we change the position, but it means something else. Okay, so the first one is probability of probability of B given A. Second one here is like probability of A given B. Okay, so the word given here is condition. So if you see the word given that condition on if, it means like that is the conditional probability. Okay, and what does it mean? This is the meaning here. A conditional probability is the probability of an event occurring given that another event has already occurred. This one is very important one. Okay. I will explain this one using the tree diagram. This one, yes, you cannot see. Like if I explain this one, like, oh, what are you talking, sir? Okay. So take this one first, and then we can relate. When we have an example, we can relate to this one. Okay. Now we have table. Okay. The table below shows that the result of a study in which researchers examine a child's IQ and the presence of a specific gene in the child. Find the probability that a child has high IQ given that the children has the gene, does not have the gene given that the child has a normal IQ. We have a problem here because they don't give the formula. Okay, why they didn't give the formula? Alright. Okay, we go back to this one. Okay. So first one, you know this one is like conditional probability. Agree? PB given A. And the formula is this one. A PB given A. So first one, PB intersect A divided by PA, I think. Divided by PA. Yes, this is the formula, guys. Okay, so we have here, this one is like PB given A equals to PB intersect A, not multiply, divide by PA. Okay, and obviously we do have conditions. Our PA cannot equals to 0. And let's say if you're like, just now I write this formula, right? P A given B, right? So how do we write formula for P A given B? If you compare with this formula, like this one, this is the formula. If that one, what is the formula? P A intersect B divided by PB or PA? PB. Okay, this one condition is PB does not equals to 0. Alright, so important one here is this is the condition on A, given on A. Okay, so if you have this condition, we should divide by that condition. This one condition is on B or A? B. That's why we divide by PB. Okay, this is the you need this formula. Okay, and next question is, if you notice this one, PA just now I said PA given B does not equals to PB given A. Agree? They are the same. If you can see the formula, they are different. How about PA intersect B and PB intersect A? Are they the same? Yes, they are the same. Let's say I ask like Mio and siapa Syahmi eh? Mio and Syahmi. They are the same like if I ask Syahmi and Mio. That's why PB intersect A equals to PA intersect B. Okay? Okay, now try this one. We have answers there. Okay, try. Try first before I explain. If you do wrong or if you do mistake, it's fine. At least you learn from your mistake. I don't want to say anything, try first. Try now. Answer is there. I hope the answer is correct. Okay. So if you have different answer, don't worry. Talk and we will see. Probably you are right, the answer is wrong. Or probably you are wrong, the answer is right. It's okay. Okay, do now. My suggestion is this way, because like the formula just now like in terms of A and B, right? So probably like you confuse a bit. Like let's say we define this one as G, this one should be G bar. High IQ, let's say we define H, normal IQ we define N. Okay, so now we have like alphabets. Okay, so first question, has a high IQ given that the child has the gene. So this one what we are talking about, P H given G. Yes, fine. Come on, I can relax a bit. I am fasting, guys. In case. Come on. we are talking about P here, guys. We're talking about P, not like how do you get? There's something you put there like over here, right? The PC, right? How do you get P? P is like NG divided by NS. PG is correct, but the PG is correct. The question is, how do you get PhD dapat dah jawapan tu 0.458. Dapat? Or ask me the question again. I will answer the question. No, I didn't say you can tambah. No, answer first question first. Second question, does not have the gene? 30/102. Right? Yeah. Third one, does not have the gene given that the child has a normal eyesight. Ini jalan kira tu? This one? Dapat? Dapat? Come on guys. Because the test later will cover topic 2 and topic 3. Don't give me different answer from the same question. So okay guys, at least your brain is working. Okay. Can I have your attention again? Okay, now you have discussed a lot of things. When you discuss a lot of things, good, because like you will ask like a lot of questions. Okay. Okay, first one guys, I want to emphasize this one. What is your question just now? Okay, diagram. Okay. So in terms of probability, I need to answer this question. First one, we have covered the Venn diagram. Okay. And from Venn diagram, we can get some probabilities. Okay. Second one, we covered the tree diagram. And from the tree diagram, you can see which one is level, which one is branches, and where are the probabilities, and we list all the sample space. Okay. Third one is a table, guys. So this one is the third one, which is a table. Okay. So just now we see the conditional probability. Now we have so many probabilities like PA intersect B, PA union B. Now we have like PA given B or PB given A. Okay. And this one, so these questions, we have a nice tables there. And we have like gene present, gene does not present, high IQ, and normal IQ. And we have numbers there like 33, 19, 39, 11. Okay. And this one is total 52. Okay. So this total 52, what does it mean? Yes, basically let's say like we have 52 children with high IQ. And it doesn't matter either that children is like gene present or does not present. But we know like, okay, we have 52 children with a high IQ. So now we can take, okay, we know what is 52. So what is 50? Like children with normal IQ. That is 50. So what is 72? Children with the gene present. Either high IQ or normal IQ, we don't know. 30? Gene does not present. So we know the numbers outside here, right? And what is 102? Total number of children. Okay. So next question is, what is 33? High IQ? Yes. When you say that one, I like that one. You say high IQ and gene present, right? Present. You say N, correct? What is N? What does it mean? Intersect. So this 33, it means like N, H intersect G. 39? Yes, normal IQ and gene present, right? So basically N intersect G. So inside here, all the intersections. Clear? So intersection like from these four numbers, and this one is not intersection. Okay. So now we want to calculate PH PH given G. There are two ways for that. Okay. See first. I just want to explain one. So PH given G. Okay. So first one. Where can I get the template? So first one, you want to calculate like P H given G, correct? Right? And this one, by looking at this one, by applying the formula, you will have like P H intersect G divided by PG. But notice that we are talking about P and P there. Okay. So how many H intersect G we have? 33, correct? So to get PHG, this one is actually 33 divided by 102. Actually. Okay. And divide by, how do we get PG? What is our PG? 72 divided by 102. This one, if you simplify this one, you will get 33 over 72, which is 0.458. That's how we get there. Clear? Alright? Can you see? This one, if you apply the normal formula one. Why we divide by 102? That is total number. Okay. Second one is, now I want to explain what is given there. Okay. So second one, let's say if we have like P H given G, what is given here? Given G, correct? So from the tables here, I cannot cover that. I can cover here, I cannot cover that. Don't look at the, because it says given G. Just look at the column G. So if you look at the column G, how many G we have? No, G. 72, correct? So we can put 72. And out of this G, how many has high IQ? 33. Then we get like 0. Yes. So basically, what is given here? Just look at the column we need or row we want. And we can ignore the other column or the other row. Clear? So we have like two different ways here. Both are okay. Okay? Second question, does not have the gene. How do we get this one? We take, this one is conditional probability or not? No, because we don't have the word given. So this one you want to find, what you want to find here? P G bar. So how do we get P G bar? 30 bahagi 102. Dapat? Dapat? I don't want to write here, okay? Okay. Third one does not have the gene, which is what? P G bar. Okay. Given that the child has a normal IQ. This one? Capital N. So if capital N, which row you want to like ignore? Just look at here, right? So our answer is 11 over 50. Correct? Can you see 11 over 50 there? Yes, that is conditional probability. I don't know how to explain using word, but I can explain using table. What is conditional? Just look at the specific row or column, the given one, then get the values there. Clear? Okay? Alright, then you can answer the previous exercise now. Not now, after this. Alright, next one is multiplication rule, and then we stop. Do we how many? Okay, tomorrow additional rule. Alright, so next one is independent, right? Oh, here. Okay. Next one is like independent and dependent events. Okay. So my first question is, what is independent? Berdikari. Okay. Apa berdikari? Okay. Merdeka, somebody say. Okay. I think in bahasa they call it tidak bersandar kot. Correct? Tidak bersandar. Okay. Independent, bersandar, I think. Okay. Probably. Okay. So independent is, yes, the strong keyword here is one event does not affect the probability of the other. Okay. So what does it mean here is your final, I don't want to go to stats examples. Your final exam is an independent, guys. Why? Because you cannot cheat or you cannot tiru your friends. Like, it totally depends on you. Like, you have to try to answer yourself. That's independent. But let's say if I do the test here in our class here, then your eyes will be like, that is not independent, guys. Because you may depends on your friends. Okay, that is like, how do I say independence and dependent event? Okay? Generally. Okay? But in terms of statistic, this one we have like a rule like a die and a coin. Okay? What happened to a die, it doesn't affect the coin. Because they are two different objects. Okay? So that is independent. Kalau dependent is, roll a die cannot be dependent. They are always independent. Unless we put some condition. Okay? Dependent events adalah, let's say we have like, a bag. Okay? And let's say we have like 5 green and we have like 5 yellow. So if you take out one, probability of getting like green is like 1/2. No, this one I don't want to write 1/2 because you don't see probably. Let's say this one is like 5/10, right, for green, and for yellow is 5/10, and this one is without replacement. Okay, second pick, what is our G now? 4/9, because we have taken out the G. Okay, and this one is 5/9. Okay, this one, what is the probability of G? 5/9, because the first one we have taken out the yellow. G is still in there, like 5G is still in there. And this one yellow is 4/9. This one is dependent event, like the second one, because it depends on the second peak depend on the first peak. That is dependent event. Unless this experiment can be independent, if we take out the green, but we put it back. So if we put it back, that one is independent. It doesn't matter what we had. So it depends on the experiment. Okay, but let's say we draw this one. Okay, so this one is 5/10, G yellow. This one is 5/10. So this one is G yellow, this one is 5/10, this one is 5/10. I hope you can read my handwriting there. Okay, 5/10. So it says here like does not affect the probability, right? What does it mean here? This one change or not? Change. Basically it affects. Okay, this one change or not? No. So no, if like it does not affect the probability, then basically or generally or loosely speaking, we can say, oh, this one is independent. Okay? Right? Alright. That one is like in terms of explanations. So in terms of formula, this one is conditional, right? PB given A or PA given B here. Okay. If the events are independent, then we don't have to apply the formula. Straight away we write PB. Straight away we write PA. We ignore or we remove the condition 1. Because this one is B first, that's why B. This one because A first, this one PA. Okay, this one only valid for independent. If not independent, we have to go back to the formula. Independent, use this formula. If not independent, go back to the previous formula. Okay. So this one is how to check based on calculations, how to check A and B are independent. So first one, calculate the probability of PB. Second one is calculate the probability of PB given A. Third one, check they are equal or not. If they are equal, independent. If they are not equal, dependent. Okay. So probably you want to write one more. Oh yeah, if this one PB equals to PB given it independent. Okay. If equals, independent. If not equal, dependent. Alright, this one question is easy. Example 1 here. Tossing a coin and getting a head, and then rolling a die and obtaining 6. Independent or not? Independent? Yes. Because one is like coin, the other one is a die. Independent. Okay. Second one, selecting a king from a standard deck. Do you know how many cards you have?
60.
I don't know. that is the problem when I study this one. I have to buy a deck of cards so that I know how many aces, how many. That's why we have example they put here. That's why at least like we know. This is a deck of cards. Yes. So you can get cards now. Okay. Okay. Now I think I put this coin. But normally guys, I think for the previous 10 years I teach in metric, we don't have this kind of example because this card is related to something else. Normally, we always tend to think, but we can use this card to teach probability. Okay. So selecting a king from a standard deck, not replacing it, take out, and then selecting a queen from the deck. Independent or not? Yes, because from the same card. How many cards? I think we have 52 cards in total, correct? 52, right? Okay, I did. Not I mean. So like, so because not replacing it, obviously it dependent. Then, this one driving over 135 kilometer per hour, and then getting in a car accident. Probably. Okay, we might have accident in like 135 kilometer then. Smoking a pack of cigarettes per day and developing a chronic lung disease here. For those who smoke, they will say independent, okay? Okay, siapa yang jawab independent tu probably like he or she is a smoker. Siapa yang tak smoke tu dia akan, okay, this one dependent, so that's why I don't smoke. Okay, what do you say? Dependent, not independent. So if you see somebody, if you see somebody smoking, you can say this one lah. This one is independent. This one dependent. Nasihatkan dia. Oh, independent ke dependent? Dependent. Siapa yang independent kat sini? Benda ni? That is good question. Mio independent. Syahmi. Mio dengan Syahmi independent. The rest are dependent lah. Okay. Last one, this one, exercising frequently and having a 4 grade point average. This one? This one tak ni lah. This one like, no, this one it can be both lah actually. This one like not very strict. Sometimes like ada, okay guys, sometimes like when you exercise frequently, yeah, you can get, it depends. Like this one, I don't know why the example is very like not really concrete. Like there is only one answer. This one you might say like, sir, I exercise regularly, I get 4 flat. Yes. Somebody say like, I exercise regularly but I don't get 4 flat. So like, this one is not a concrete answer. Okay, like the cigarette just now, depends on types of are you smoker or not. Okay. Syami. Wow, you have a lot of exercise, guys. Okay, I will cover multiplication rule. Two slides only. Tomorrow we can finish early. Oops. Okay, multiplication rule. So first one is multiplication rule. Just now we said multiply or darab. Correct. Don't stress yourself, guys. When I cover the topic, I always like read the subtopic first. And then try to know, okay, this subtopic, what is it about? Like, oh, okay, at least you know a picture a bit, right? So this one, multiplication rule. My first question is, how do we get this formula? From where? Correct, from somewhere. Yes, terbalik ataupun susun semula. Because previously we have like P A given B equals to P A intersect B divided by PB. So what happen if you susun balik? So we will have this one, correct? Oh, down. No. Because this one is not P A given B. This one is PB given A. So let's say we have like PB PB given A, this one equals like PB intersect A divided by PA. So if you rearrange this one, PA, there is like an indicator we should stop to. Okay. So it's PA. Okay. So if you rearrange this one, then you will get this one. Agree? That's how we get the formula. Okay. And you may ask, where is the multiplication? This one? Like we take PA multiplied by PB given A. The small dot there basically it means multiply. Okay. So if somebody asks you, how do we get the multiplication rule? You can say, from conditional probability. We rearrange and then we get PA multiplied by PB given A. That's multiplication rule. Okay. And next question is, how do we simplify this one? This one equals to PA intersect B equals to PA multiplied by PB. So if you compare this formula, this one is the same, correct? And we have PA, we have PA. But only like PB given A, now it becomes PB. How come we can write like PB given A equals to PB? When the events are independent. So what does it mean here? If we don't know event A and B are independent or not, we apply the first formula. Second formula, like if the question mentioned A and B are independent, then you can apply the second formula. Alright? Third one is, if you know the experiment is independent. Okay, like rolling a die and tossing a coin was always independent, then you can apply the formula straight away. Okay. Okay, try examples there, guys. Then we can go. What is the probability of selecting a king? Yes. Two. The independent smoker just now? This one 4/52, agree?
Yes.
Why 4? Kita ada king part. Why 52? Total card. Okay. Clear? And then selecting a queen. And then we have without replacing. So if we take one card out, how many cards left? 51. And how many queen we have? 4. So first one is 4/52. Four over 52 multiplied by 4/50. Why 51? Because without replacing. Basically like one card is out already. Yes. This one ask the card expert. Okay. Or you can use the diagram here, count how many king. This one is not very clear. Which one is king? I don't know. Last one. This one is what? Oh, J, Q, K. Oh, okay. Yes. 1, 2. I believe you 52. Okay. And second example. A coin is tossed and a die is rolled. Find the probability of tossing a head and then rolling a 6. So tossing a head, what is the probability? 1 over 2. Rolling a die? 1 over 6. Answer? 1 over 2. Got it? Dapat? Okay, now exercise 1, exercise 2, exercise 3, exercise 4, done. Additional rule will